Hi guys, Miss Raymond here. We're going to talk today about writing covalent compounds from their names. Okay, so remember before when we talked about covalent or molecular compounds and how we said that it's all about the prefixes. And the prefixes indicate the number of each type of the element. Now remember that covalent compounds are non-metal only. So we are not dealing with charge. There's not going to be any kind of charge involved here. There's not going to be any kind of Roman numeral. It's just prefixes, okay? So when we're doing this with the prefixes, we have to remember what our prefixes are. So I left them on the screen here for you. And of course, you want to make sure that you have these somewhere in your notes and that you memorize them at some point. So our first one is sulfur trichloride. So think about that, sulfur. If I don't have a prefix with the sulfur, how many sulfurs do you think I have? If you thought one, you'd be correct. So that would be plain old S. Now the trichloride, I have to look down here at my prefixes, and tri means 3. So that means I'm going to have 3 chlorines. So that's SCl3. Now, notice I didn't look at the periodic table for charge. I didn't think about charge. I didn't crisscross charge. Nothing to do with charges. It's only about the prefixes. The prefixes tell me the name. And that's because I can have sulfur trichloride. I can have disulfur pentachloride. I can have lots of different compounds out there. So I need to make sure that I look at the prefixes to indicate how many I'm going to have of each atom. Go ahead and try these next 4 on your own by using the prefixes below and using the periodic table for the names. If you're having trouble with it, then go ahead and come back and play it and see what I put. Okay, so hopefully you paused and now you're checking your work. Our next one, tricarbon disulfide. So tricarbon is telling me I have carbon, but I have 3 of them. Disulfide is S with 2 by looking at my prefixes. Now, if you haven't paused yet, go ahead and pause and try the last 3 on your own. Come back and check out my answers. Here are the answers for the last 3. The next one here, phosphorus pentafluoride, the penta is 5, so it's PF5. Silicon dioxide, we use that one in our lab, and silicon is plain old Si, and it's dioxide, so it's O2. Now, I know that Si is a metalloid, so a lot of people think that you're supposed to treat it like a metal, but we can treat it like a non-metal in this case, or in most cases, and we can use our prefixes instead, and that's what you're mostly going to see when we're dealing with the metalloids. Our last one here, dinitrogen, tells me I have 2. Tetrabromide tells me I have 4. Now this one, if I had to guess, you might have reduced this to NBr2. But there's a big difference in compounds when we're dealing with molecular compounds. There's a huge difference between NBr2 and N2Br4. They are not the same thing. They are not equal. Okay? The reason why we can do that with ionic is because ionic is all about the exchange of charge, and so they're trying to get the best ratio, the smallest ratio that's going to exchange that charge. But with covalent, it's not about exchanging charge, it's about how many want to come together to share in order to make this particular compound. So in one case, you might have 2 nitrogen and 4 bromine making this really big compound, but then you would have a totally different compound that has very different properties that would have 1 nitrogen with 2 bromine. So make sure that we do not reduce covalent compounds, that we leave them as is based on that name. Okay? All right, hope that you get some more practice. If you're still having some trouble, make sure that you do the problems in the back of the chapter and work on your worksheets. Otherwise, come see myself or Ms. Schwemmen before or after school.